Hi, in this video I'm going to show you how to capture wireless traffic on an Aruba access point remotely to capture PC using Aruba-ERM, which stands for Encapsulated Remote Mirroring. This is a feature that started with Aruba AOS 8.4 and later. So it's not new, but it's kind of cool to see it done. You can do it in the GUI and you can do it in the command line. The GUI requires a mobility conductor or mobility master, and I don't think it's possible to do it on the standalone controller unless you do it on the command line. There's some additional features on the command line as well that we're going to look at just briefly. But overall, I'm going to show you how to do this through the GUI, show you what it takes to do it in Wireshark to receive those captures, and then also how to do it directly on the controller with the command line with maybe some capture filters and explain those a little bit. So here in this mobility conductor, we want to just go to our access points and select the one that you want to capture on and click this packet capture icon, which brings up a little window here that you want to type in your IP address of the host that you're going to capture to. Port 5555 is the default, and we probably want to just leave that alone unless you have reasons to change it. And then you want to just select your band. In this case, I'm going to capture 5 gigahertz. The format has a lot of options here. If you have OmniPeak or Air Magnet, you may want to select those. And then if you wanted to capture the additional 802.11 header information or radio tap headers, then you probably want to select PCAP plus radio or radio tap. In this case, I'm going to choose a radio tap because I might want to look at those radio tap headers to see some signal strength, other radio information that you don't get in the straight PCAP. So once we start that, it's now capturing that at the access point and sending it off to this IP address. And you can see this icon is turned green there. But we're not receiving that yet in Wireshark. So here I want to show you how to set up Wireshark to receive those Aruba-ERM captures, which isn't too complicated, but if you haven't done it before, it's a little bit buried. First thing you want to do is go here to Edit and Preferences, and we're going to find that Aruba-ERM protocol, and we're going to set that that port number, which UDP port 5555 is what we left at default. We select OK there. And then under Analyze, I'm going to do Decode As. And this line here we just added when we set that port. But we want to add another one here for Aruba-ERM. And this is the Aruba-ERM type, which is those same options that you saw in that window that popped up. In this case, we chose a radio tap type 6. And if this is incorrect, then it's going to show, it's not going to be able to tell or decode those frames correctly. So it might show fragmented frames or other errors. It's not necessarily true, but so it's important that these do line up. So I'm going to go OK there. And then the last thing I want to do before I start capturing is set this UDP port 5555 using a capture filter on the Wireshark side. Otherwise, I'm going to get a lot of noise from my Ethernet adapter interface, traffic that this host is doing. That might make for large files or difficulty in kind of looking through those files, stuff that I don't necessarily want to look at. So let's go ahead and start our capture. And it looks like we are seeing these 802.11 frames here. And one thing that's interesting is because it's encapsulated, you'll still see these Ethernet frames, IP frames, or sorry, Ethernet headers and IP headers on there on the packet. And then we can get down here into the radio tap and the 802.11, and then the contents of that wireless frame. So it's just a little bit different than capturing over the air, but all of the information is there. And in most other aspects, it's exactly as if you were to capture over the air. Although it is the access point doing the capture instead of a tool. So for that reason, it's very convenient. This doesn't disrupt the operation of that access point. It's going to capture its own frames on the way out, as well as any other frames that it detects and can decode. In order to stop that, I'm going to just go back here and click this icon again and click stop. And we'll see that we've stopped receiving traffic here. I'm going to go ahead and stop this here. And then next, I'm going to show you how to do this on the command line, which requires us to change the type. So the default decode type is actually 0. And in this next capture, we're going to use type 0. So I'm going to change that now. And you'll want to just make sure that this is lining up correctly with how you're configuring that capture. So I have another controller here that is not on a mobility master mobility conductor, and the access points here are listed, but we don't have that capture icon. So I'm going to go ahead and SSH to that controller, and I'm going to open up the port AP packet capture open port. So that's that same UDP port that we want to open up to allow it to come directly from the access point to this capture PC. And then with the capture types, there's interactive and raw start captures. Interactive is going to give you a little bit more options as far as capture filters. There's type, being beacon, or other, management controller data frame types, station, BSS, destination or source address, direction, retries, and a few other options there that you can do some capture filters on, really to drill into that. So we're going to do an interactive capture, which does use that type 0. And I'm going to filter this one on type is beacon. And you do need to specify the radio that you're going to use. In this case, radio 0 is the 5 gigahertz radio. So now we've started that packet capture, or that capture and send from the access point. It's giving us an ID that you can check with the show AP packet capture status. But we should be able to start this capture again. And I'm going to be getting those beacons from that access point, or at least a capture filter on those beacons. And in this case, it looks like it's just beacons from the access point itself on the way out. One interesting thing that I noticed with Aruba access points with this feature specifically is that when you are capturing, it's only sending one beacon per second, or one set of beacons per radio per second from the access point that's transmitting and capturing. I looked into it and I checked around, and it looks like that is expected behavior. It's just something to know about. I'm not receiving the 10 beacons per second that I would normally expect. If you really needed to capture all those beacons, you could capture from an adjacent AP, but it would need to be on the same channel as this transmitting radio. Okay, so I'm going to go ahead and stop this capture, and that's done by running AP packet capture stop, and then the AP name again there. And then you do need to, for some reason, put in that ID and the radio 0. Maybe that's maybe it is possible to capture on multiple radios at the same time. So that is stopped, and then I'm going to go ahead and close out the AP that port. Close port 5555. Okay, so now I am no longer transmitting or capturing those frames. This has been a really useful tool that I'm excited to use more for troubleshooting and other projects, to gather information on access points that may be in an area where I can't physically get to, or might be quite disruptive if I was to go and interrupt a class or some other activity to get into there. But I can do this without disrupting them, but also gather that complete capture, whatever capture I want to filter on. Anyways, I hope this was useful for you or anybody, and I'm excited for it. Have a great day. See ya.